To photograph the planets, a telescope with a long focal length and a high f ratio are recommended. This particular telescope here is the Celestron 11-inch Edge HD. Now, it has a focal ratio of f10 with a focal length of 2,800 millimeters. That's a long focal length, but you need that to get good images of the planets. Also, a camera with a smaller pixel size is also recommended. Now, you can use other cameras with pixel sizes, say 3.6 or even up to 5.96. But this particular example here, I'm using a planetary camera, and most planetary cameras have a pixel size of about 2.9 microns. And I'm using the Uranus C, the Player One Uranus C camera on this venture for tonight. Now, the planet in question is the mighty planet Jupiter. Jupiter, the largest planet in the solar system, will be coming into opposition in about 2.5 weeks. January 10th, 2026 will be this year's, or this period's opposition time. That's when the planet is at its best viewing. That's when the Earth is between the sun and the planet. So we're seeing the planet at its best and its closest range as well. And I want to show you in this video how I capture the planet using this telescope and also the software that comes with the Celestron type mount. This is the CGX mount, and the software is called CPWI, and also a program called SharpCap. I'm also going to intertwine that with Nina. So SharpCap, Nina, CPWI, the telescope, the planet Jupiter. Let's do some photographing, and I want to show you how to do a time lapse using SharpCap. Welcome to Heavenly Backyard Astronomy. I'm Pat Prokop.
Wait till you see what SharpCap does in live stacking with this planet right here.
Now, if you're watching this video here, this is the short video where I just basically cut to the chase, showing you how I stack and build the animation. Now, if you want to know a lot more information of what's going on behind the scene in SharpCap, for what I know up in SharpCap, you can look at what's I call the longer version of this video, which is about 35 minutes long. So, but it's filled with great information. So again, this is the short version. So welcome to Heavenly Backyard Astronomy.
SharpCap, I mean, this program has gone so far over the last several years. It's amazing, particularly for planetary and also for the deep space now too, for this live stacking routine that it has. All right, let's go into the cameras. Let's find it. There it is, the Uranus C, the IMX 585 camera. The Player One. Yeah, look at that. There it is right there. And it's pretty doggone close into focus right now. But let's go into, back to CPWI. Let's go into the telescope. Let's go to slew controls. And let's bring that up. Just bring it over here. While I'm in here, I found out this is very important if you're going into do some planetary versus deep space. You want to make sure the telescope is tracking in the correct mode. So go into here, go into configure mount, and then go over into tracking rate. And I have it set to, you have it set, usually it's on sidereal. That's for deep space. That tracks the stars. Or you can track the moon. But if you're doing planetary, you want solar system objects. So planetary is what you want solar. So click on solar. And then come down all the way down to the bottom here, scroll down and say accept. All right, so now it's going to be tracking with the planets. All right, next thing I want to do, slew controls. I'm going to bring this back down a little bit because number 9 would be way too fast. And I think this is left and right is left. Yeah, bring it over. All right, so I can turn the reticle off. That's just, well, no reticle. Okay. All right. So the next thing I want to do, I could just keep this out of the way for right now. If you're into SharpCap, first of all, you want to make sure the planet looks something like this. Hang on, let me zoom in a little bit here for you. And all right, so you can see I'm a little bit out of focus, but we're going to play with that in just a minute. But you also want to come down to the image controls, and you could go with auto. And you might want to, let's tell you what, let's just leave it on auto for right now. And that's going to be a little bit of a greenish reddish hue to it. All right, let's play with the focus now. So you can see it's, particularly on the edges, you can see it's a little off. However, as I'm right now set this, I have the settings at 10 milliseconds. That's very, very fast. I'm getting 36, 38, almost 40 frames per second. And this is at a full screen, so hang on a second. All right, so let's just bring this up and see if we can see the moons. And I found it's easier to focus if you focus on one of the moons, particularly the two brighter moons, Io, or I think it's Ganymede. So let's just bring this out just a little. Well, this is good. Let's go this way. Is there another moon out there somewhere? There should be 4. Oh, that one's behind the planet right now. Okay. Anyway, let's focus in on this moon, these guys right here. So let's just play with the focus. And let's go with it. I think that's going to be pretty good. Let's bring this back down to 10 milliseconds. I'll just type it in. A lot easier. Okay, and there's Jupiter. Yeah, now if you look at the edges, you can see it's a lot less fuzzy. You can see the banding already in the atmospheric belts. Now, I think that might be pretty good because I want to get the moons as well. All right, let's go back to the full view, which is auto. There's the full view. That looks pretty good in itself without the SharpCap. Wait till you see what SharpCap does in live stacking with this planet right here. Okay. Again, I'm going to pull it out of the, not focus, I'm going to pull it out of the gain. I'm going to bring the gain up. Let's just, see, at 250, let's just bring it up so I can see. I want to see the moons. All right, so I want a frame kind of like in here because I want to track the moons because we're going to build an animation in this. So I want to track the moons. All right, so now what I like to do, first of all, in this, for some reason, I think it does better in RGB. You have the options of raw 8, 16, or mono 8. Or RGB 24. So I'm going to use RGB 24. And the region of interest, I'm going to probably take it at the 1280 by 1024. Okay, they're in there. Of course, now the bigger the frame is, the slower the frame rate's going to be. But I want to get these moons. I tell you what, let's push the planet over a little bit, but I don't want to use it with the slew. I'm going to just use it with the region of interest right here. I can move this around, see, and with the mouse, or I can fine tune it with the pan and tilt. Tilt is up and down, pan is left and right. Let's just go a little bit more left. Okay, a little bit more right. Let's just do it there. I'm assuming these guys are coming in. This one's going in as well. Hopefully, we'll see. All right, let's bring it back to 250 on the gain, analog gain, 250. Okay, there's a beautiful picture of Jupiter. All right, so let's go into the magic over here, and let's type in not live stack, but planetary stacking right here. Start stacking frames for deep sky imaging and, in this case, planetary. And they're already starting to stack. And I can adjust the values over here in the stacking. And also I can adjust the sharpening. If you want to, first time you're through it, you can click on the Get Started tab, and it gives you some things to do and so forth. Small planet, large planet, like in this case, solar, partial solar, lunar, and so forth and so on. Excuse me, and so on. But look at already, this is it's picking up the moons. There it is. All right, it's picking up the moons. So, so go into frame filtering. That's important. Now, what I have it set here is I am accepting only the best 15% frames. So all that atmospheric dispersion and what else is going on, because it's still kind of low in the elevation. I'm filtering out a lot of that. So I'm getting most of the frames being filtered out, but if you look over here, it's stacking. I've already got 500 stacks. And I told it to go ahead and stack up to 3,600 in this particular example. While we're doing that, you also have, I'm going to skip this for a second, the time lapse. Let's go into stabilization alignment. And this case, it's a planet full disk. All right. Now, if you're shooting the moon, obviously you click on surface. If you're stacking mode, I want to do a multi-point stacking. If it's a smaller object like Neptune or Uranus or Mercury, you'd want to use a single point. But any of the larger planets, Mars, Saturn, and Jupiter, and Venus, you want to go full disk. All right, and go multi-point. And then you can go show alignment points right here. And these are the alignment points that it's looking at. So it's not looking at the moons. So it's going to keep this portion of the view in the center of the object that it's stacking. Okay, and even if the planet drifts left, right, up, down, it will put it back here right in the center, and which is going to be really good for when you're doing the animation. So I just leave this at 4, and contrast threshold, I leave that at 1.5, whatever. And track planet with SharpCap selection area, track planet with camera region of interest, which we're doing, and also realign color channels. It's looking pretty clean at the moment. Now, also, you can look over here in these buttons down here. Show unprocessed frames right there, unprocessed frames, and there you can see the actual planet itself. If I click on that, that's the stacked images, and with the image sharpened and colorized. Also, if you look at half and half, this shows the two side by side. You can see how the live planet versus the stacked planet are aligned with each other. And you can see it's guiding really well with the CGX mount in the solar tracking mode. So we just hit 5,000 frames, so I'm going to hit this, and then I'm going to go over here, save as a 16-bit TIFF file. I'll just do that, and it saved it right there. Images, where are we? SharpCap files right over here. Here we go, December 26th. There's the image right there that I saved. I mean, that's not bad. Not bad. It's a little fuzzy still, again, but it's low on the horizon. Let's take a look at Nina. Look at the framing, and you see right there, it's still only 33 degrees above the horizon. So I like it when it's at least 45 for planets, 45 degrees above the horizon. I know if you're up in the northern latitudes, you're not going to get this 80 degrees transit elevation. I'm here at 32 degrees north latitude. So if you're up in the England or whatever, you're only going to be at about 50 degrees transit. 30 degrees from 60. You might get up to 60 elevation, 60 degree elevation. All right, let's go back to the SharpCap, and I'll stop blabbering here, babbling. SharpCap, come on, bring it up. There we go. All right, I'm going to bring this back down now to 15%. Right there. Do filtering of the shows. All right, let's just zoom in. I could zoom in here. We got to, let's just go 150. Take a, see, that looks pretty good. All right, let's bring this back to normal size. All right, let's go back into planetary stacking to here. Yeah, that looks pretty good. Okay, let's see if I can get the moons. Let's bring up the, I think I have it over here. My bookmarks, Jupiter, JavaScript, Jupiter, and yeah, I got it right. So there's Europa, Ganymede, and Io. Callisto's way over there to the right out of the picture. So, yeah. There's Europa, Ganymede, and Io right here. So if I go, I'll put the link to this little JavaScript on here. It was, shallowsky.com Jupiter. Okay. Let's see. Let's advance an hour. Look around here, right here. Advance an hour. So Europa is moving away, but Ganymede and Io are moving in. And I don't see the red. There's the red spot right here. So it's way over there. It doesn't show up until, oh gosh, another 2.5 hours, 3 hours from now. I'm going to stack it every 2 minutes. So however many frames it gets in 2 minutes is what it's going to stack with. It's going to be about the same each time. As it gets higher up in the sky, actually, I'll probably get a little bit more image stacked than is at the lower altitudes, because you get a better image. At higher the altitude, you get less atmospheric diffraction going on in. Now, I'm going to save it as a TIFF image. You can save it as a PNG image, or AVI video, or SER video, or a WMV video. However, I found out you're better off, in my opinion, if you just make a either TIFF image or a PNG image. And if you have a your own editor, like I have, you can then re-edit the animation when you're done. Or you can also do this. Click on this little check mark here, create short animation GIF file or GIF file when completed. And it'll give you 2 different files, one forward and one going forward and backwards. That's kind of neat. So I'll show you that at the end of the video as well. So I'm going to reset the stack after every image. So in case there's any artifacts that show up, like, around here, I'm close to an Air Force base. An airplane passes overhead, leaves a big old streak across the image that will destroy the stack. So I have it, after every image, I have it to reset the stack back to 0. So I get a clean stack every time. All right, so once again, in 120 seconds is the maximum you can stack at. You can stack lower, but you can't stack any higher. Excuse me. You can't stack any higher than 120 seconds, which is what, every 2 minutes. Now, if you really want a smooth image, you can lower that down to a minute or even 30 seconds. But then again, you're going to have less stacked frames. But, with Jupiter, you don't want to go too much longer than 2 minutes. Now, with Saturn, you can go much longer if you wanted to, but you can't because you only get the option of up to 2 minutes. Mars, again, it rotates almost the same speed as the Earth. Mars is just a little over 24 hours. But Jupiter at 9 hours, 7 minutes? Something like that. Just under 10 hours. So it's really flying through. As a matter of fact, if you look carefully, you can see the equatorial area is a little bit bulgier at the equator than it is at the poles. Because of that fast spinning rate, it bulges out the equator somewhat. All right, so let's quit babbling and let's start time-lapse. As soon as I hit start time-lapse, the stacking length here is going to go back to 0. So before I do, let's just take a quick picture, look at the unprocessed frame. See, the mount is guiding perfectly. So, all right, so let's hit start time-lapse and let her rip. All right, and it's going to be counting down over here how many frames you have and so forth. It just recorded the first frame as a stacked, and then from here on out, it's going to start adding. Also, there's another here. Oh, yeah. You have these other options to play with. You can put add a timestamp on the top. We can do that, add that. Well, you can't add it once you start. You can't change these things, but you can add a timestamp to the image if you want to. Each frame will have a timestamp. And I also clicked on Save an Extra Time-Lapse File with the Unsharpened, Unadjusted Image. That's this one right here. So it'll save that image, and it'll save that image, the stacked image and the raw image. So you can use that as to compare. Really, in my opinion, you don't really need the extra image because it's just going to take up space and you're just going to end up deleting it anyway, unless you had something, get off my screen, unless you had some artifacts that messed up the image and so forth and so on. But there's the, what did we say that was? Io or Io and Ganymede, and that's Europa over here. Okay, and the red spot is somewhere on the back side, somewhere around here on the back side. So it's got to come around and then start going this way. So the planet should be rotating this way. Okay, so these guys are coming in. Europa is going away. And Callisto is way over here, somewhere off the screen. I have some clouds pushing into the area now. I already got 5 frames added, but looking at the satellite imagery right here, I am located right about here. And there are some clouds passing in across my area, so that's going to cause some problems. And then I'm beginning to see some more clouds coming in from the west, so I might not get a full night's view out of this system this evening from this. But you're getting the idea how to do this anyway. So let's minimize this, go back at the planet itself. And I'm losing Ganymede and Io, and I can barely see Europa over here because those thin clouds passing overhead, and that's causing the planet to blur somewhat here. Let's go back to the stacked frame right there, and there you can see the Ganymede and Io and also Europa over here showing up in the stack. But I'm not getting the best of stacks. But let's take a look at the stacks anyway. And let's bring those up right now. There are the stacks so far. These are the images of the stack every 2 minutes. And these are the raw images over here. So let me bring this up here. Just go full frame, make it a little bit bigger for you. And we go 5 frames. You can see now if I have it correct, it should be rotating from the left to the right. In other words, counterclockwise. And let's see. Yeah, it's rotating counterclockwise, all right. And that's the last frame there. There's the raw images there. You see how it bounces around? But with the stacked image in SharpCap, it keeps it locked in the center, which is kind of neat. Also, let's see if we can see that if the moons are moving. Europa they all should be moving from here to this way, because Europa is moving out away from the planet, and the Ganymede and Io are approaching the planet. Let's see if that's true. Yeah. There they go. See, and I got a little fuzzy there because that cloud's coming in, okay? All right. Let's close that off. All right, let's bring that down here. And there's a stack. See, I'm not getting very many stacks right now. And there it goes. Little patches of thin, wispy clouds are passing over the target. So that's messing things up a little bit on this evening. So I don't have the best clear skies, even though above the atmosphere is quite quiet. So that helps. If I can get more clear skies, I'll get some really good, clean pictures. But I don't think I'm going to get much after about midnight tonight. Those clouds off to the west are going to make it in this way. Maybe. Maybe not. So here's the saved picture of the planet with the moons. You can see on to the right Io and Ganymede, and to the left Europa. And that's a good looking picture. And this is a picture here from the 2 nights before. I had a clear sky. I took Jupiter, and you can see the giant red spot. You know, that giant red spot is so large you could fit 2 Earths in it side by side. But there's the great red spot there. Now, I want to show you the GIF animation, or GIF animations, and this is the image from 2 nights ago when I had clear skies, and there you can see the animation of Jupiter, and definitely rotating. You can certainly see the belts and everything rotating cleanly. And this is the other GIF file that it makes, and it's forward and backwards, forward and backwards. It goes forward, then it goes backwards, and then so on and so forth. And they're kind of neat. You can really put these up on your websites or your social media pages too. Anyway, and this is the animation I made taking the raw TIFF files that I saved, and I put them through the editor I'm using right now to record this, and made this animation here of Jupiter. Well, I tell you what, it's amazing.
I got to tell you, in the past, I had to shoot AVI files or other video files, and then go over into auto stackered, and then process the video from there to get an image, and then from there I had to go into Registacks to process the image after that, and then after that going into Photoshop to polish it up even more. basically, SharpCap, the new version right now, is doing all that, putting all those other programs to rest. So really, all you need is the software is SharpCap to get these fantastic images and the animations. Watching Jupiter rotate, it just blows my mind. And seeing the moons moving in and around their orbits, I just wish I had a longer period of time. The clouds moved in. I have a video I showed you also from a couple nights before where I did have a longer night's view, and the animation of those are coming in right after this. So thanks for watching. I appreciate all those who have been supporting my channel and my members. I really appreciate that. And you could click the membership if you'd like to join my channel or support my channel by sending me a super thanks or looking into my Patreon page or buy me a coffee. Anyway, the planets are, well, Jupiter is coming into full view. Mars is getting out of the picture now. Mercury is low in the evening sky, and Saturn is low in the southwest at sunset and basically moving out of view. Venus is just about behind the sun right now. It'll be coming out as the evening star sometime around February. Then going into the spring months, we'll be seeing Venus. And I'm excited to see how this stacking program works with the planet Venus, because Venus is extremely hard to photograph, but I'm excited to see how the new version of SharpCap will handle the planet Venus. So remember, the heavens are filled with majestic objects. Not only the planets, but the nebulosity, the galaxies, the star clusters, all that up in a sky near you. So unless you need rain, clear skies, everyone.